These ducks were raised on a farm where they hatched by the thousands in large incubators. Born in a drawer, you might say, where they see neither their parents nor any other adult ducks. Does this situation affect their behavior? Do they still show the need for a parent? To find out, behavioral scientists developed a series of experiments. Fertilized duck eggs are put in cardboard cylinders and placed alone in incubators where each is completely isolated from all light and sound. About 10 hours later, the bird gets its bearings and makes what sounds like a distress call. On wobbly legs, it seems to look for something, even though there's virtually nothing to see in the experiment's featureless environment. At least, not yet. But a mechanical toy is about to enter the picture. Watch what happens when the duckling discovers its first moving object. The duck shows no fear. On the contrary, as it watches the toy's movements, it stops making distress calls and begins a calm peeping. In this time-lapse sequence, notice how the duck gradually develops a behavior pattern. After just minutes of exposure, the duck eagerly approaches and follows the toy everywhere, just as it would normally follow its own parent. It peeps contentedly, seems completely at ease, and willingly accepts the toy, as well as an unexpected piggyback ride. Is the duck's acceptance also attachment or dependence? To find out, the toy is removed. There's no doubt about it. The duck sounds the distress call and searches for the object. When it returns, so does calm peeping. Apparently, the duck has adopted the toy as its parent. Does the color, sound, or texture of a toy affect the experiment? To find out, it's repeated with a different object and a second duckling. Again, the duck is 10 hours old and the toy the first object it's seen. And again, the animal peeps contentedly, approaches, follows, and responds to the toy as it would to a parent. Duckling 3, Experiment 3. The first two used toys that made sounds. To see if sound is significant, this experiment uses a silent toy. Though the balloon is silent, the duck's behavior is the same. Duck meets object. Duck follows object. Duck adopts object. And gets mighty upset when the object disappears. Again, the duck searches for the object. When it returns, there's no question that the duck recognizes it on sight. What if the object isn't a toy at all, but a rabbit minding its own business? Well, here comes duckling number 4, fresh from isolation. What will happen when it meets the seemingly skeptical cottontail? Another time-lapse sequence gives the answer. Despite the rabbit's initial reluctance, the duckling prevails, and in the process repeats the behavior pattern shown in the first 3 experiments. The pattern can be observed with almost any object, be it live or mechanical, noisy or silent, regardless of shape. When it's the first moving thing a duckling sees, the duck approaches, follows, recognizes, and soon depends on the object as it would on a parent. This behavior pattern is what's meant by the term imprinting. To Konrad Lorenz, who first observed it, imprinting proved that while ducks seek a parent by instinct, they come to recognize one only through learning. Lorenz also found that imprinting has limits. This duck is not 10, but 30 hours old. Watch the result as it meets the mechanical mutt from experiment 1. Would you call this approach, following, attachment? Hardly. The 30-hour duck wants nothing to do with the toy, so this experiment's result is the direct opposite of the first one's, even though all that differs is the age of the duck. What happens if we try it again with a different toy and another 30-hour duck? Scared? You bet. These experiments show that imprinting must occur during a certain time span, or it won't happen at all. The span is called the critical period. It begins 3 hours after birth and ends at about 30 hours. At a peak age of about 16 hours, a duck will imprint more easily and quickly than at other times during the critical period. Once imprinting has occurred, will it last? This real duck has firmly imprinted the mechanical one. The two are color-coded, and the duckling joins some others that have been exposed only to each other. Watch what happens 24 hours later. Even after a day, the duckling recognizes the toy. Not only does the imprint last, but appears every bit as strong as it was 24 hours before. And notice what's happened to the rest of the brood. Having been together throughout the critical period, they've imprinted each other. Once a duck has imprinted one toy, will it shift its preference to another? To find out, a second duck gets a necktie. So does a third. Once again, watch what happens after 24 hours when ducks and objects are reunited. The result is clear. Each duck has formed a detailed enough image of its own toy to remember and distinguish it from the others. The learning that results from imprinting is not only lasting and firm, but astonishingly precise. What happens in the laboratory also occurs in nature. Newborn ducks seek and follow the first moving object they see, which usually happens to be their mother. Within hours of birth, the ducklings have a firm attachment to her and a lasting, precise image of how she looks. They keep her in sight, assuring themselves food, warmth, protection, and a guide back to the nest. Imprinting has also been seen in other animals that can walk soon after birth. To scientists, imprinting is important as a link between instinct and learning. As for the animals themselves, it's a behavior that helps ensure their very survival.